Hi, I'm going to reveal the answers to the practice tests 11, 12, 4, 5, and 6 to help you study. Now, this isn't really homework. That's your other sheet, but this definitely is going to help. And if you're a geometry student, this is statistics. So do not watch this video unless you want to be confused. Okay, now it says, Mr. Yates picked up a dozen items at a grocery store and the mean or average cost was $3.25. So all that means is you added up 12 items, and when you added all those up and you divided it by 12, you got $3.25. So that could mean that one item was $3.25 and maybe the other one was $3 and the other one was $3.50. So it could be $3.25, $3, $3.50, $3.25, $3, $3.50, $3, $3.25, $3.50. All we know is that all those numbers add up. 325 times 12, all of those add up to 39, and when you divide by 12, you get 320. So all of these, all the items added up to 39, and when you divided by the 12 items, you got 325. That's the only thing I really know so far. Okay? Is the average price is $3.25. Now it says, then he added apple pie for $6.50. So I have 12 items that I know add up to $39. And now my total bill is going to be another $6.50. And then instead of 12 items, I actually have a 13th item. So I'm going to, the new mean for all 13 items is, I don't know. So you make X what you don't know. So here, just using logic, I could set all 12 items to exactly $3.25 because it doesn't really matter. And when I do that, 12 items times $3.25 is $39. And then I know I bought another item for $6.50. And when I add those up, I get $45.50 over 13 because now I have 13 items. Divide by 13 and I get $3.50, and that is my answer. Now you could probably use some logic and probably narrow it down. Definitely you should have eliminated that one. That doesn't. One more item is not going to drive up the average that much. Also, a more expensive item is definitely not going to drop the average price. So that would have been some good ones to eliminate. Okay, let's look at 12. Now this is kind of tricky. It says it's listing these, and this is, sorry for the announcement. This is categorical data. I can still order them least to greatest. It looks like the most was US, then Japan, then Germany, then maybe Sweden, and Italy and France look the same. Okay, now you could do it in any order. We definitely need US to be the most, though. They are obviously the very most, and so this doesn't have them the most. This doesn't have them the most. I can't really eliminate that yet. Okay, I also know that France and Italy have to be pretty much the same. Okay, so there we go. So now I've narrowed it down to B and E. Okay, and I ordered them most to least. And now I just have to kind of double check. So this one was the most, US, then Japan, then Germany, then Sweden, then Italy, then France. I'm definitely going to pick B. Looking good. Okay, now 4. This is called an ogive graph, and not a lot of people have seen these. So if it's your first time, don't be afraid. Just watch the video. I'll explain. So this is a kind of, I call them a cheater graph. They allow you to look at exactly the percentage, and by the very end, you have all 100% of the data. So it tells me the maximum amount was probably 0. Or excuse me, the minimum was 0 and the max was 18. And the median, I can actually get right off of here. That's when you're 50% of the way through the data, was somewhere around 7. So the median student drank 7 ounces. But what they're asking for me here is what percent of students were moderate, which means between 4 and 8 ounces a week. So I'm just going to trace 4 and go doodle-doodle, and 8, go up and go over. So when I've collected all my data, when I talk to all my students and ordered them least to greatest, 20% of the people consumed 4 or less. That's what that graph means. And then when I talk to everybody in order of how much they consumed, by the time I talked to the people that consumed 8 ounces, they made up 60% of the data. And so they want to know between how much. So that would just be 60 minus 20 makes 40. That's my answer, C. Good job if you found that. Now, 5. This one's a tricky one. This one, unless you've been in chemistry, you might not know. Okay, so it says, if you took a reading, 36.5 Celsius, and that's the average, can you convert it to Fahrenheit? And I think that's pretty easy. Just plug it in, and they give you the formula. So that would be the amount of Fahrenheit, and if I do that, bada boom, bada bing, I get, but all of them have that. So they assumed you knew how to do that. So here's a little tidbit that maybe you know, maybe you don't know. I'm going to give you an example of, and I think you noticed that right there, that when you take the mean, that was the mean temperature, when I add something to it, it changes the number, right? The number was 36.5 degrees Fahrenheit. Now it's 97 degrees Fahrenheit. It's the same temperature, but I added a number to it. And so that's why that number is bigger than that number. Also, we multiply 1.8. So I had to multiply that to convert it from Fahrenheit to Celsius. Well, the challenge here is that's not how standard deviation behaves. It does not change when I add. It does change when I multiply. So the rule goes, anything having to do with spread only changes with multiplication or division, okay? Spread only changes with multiplication or division. Now, it makes sense that the Fahrenheit changed because that temperature is that, and I will explain the spread. But let's go ahead and do that. If I add 32 degrees to it, it's not going to change the spread, and standard deviation is a type of spread. But I will change the multiplication. So as I take 0.3 times the 0.3 times the 1.8 factor, in the formula, I get 0.54, and that's my answer. Now, let me explain why, and again, I'll write out what I got there. The spread in Celsius was 0.3, and I have to convert it to Fahrenheit spread, so I have to multiply it by 1.8. And when I do that, I get 0.54. Now, why would it affect it that way? Let me show you a really easy example. Let's say we took all of our ages. I'm 41, a lot of you are 16, maybe a couple of you are 17, right? And let's see how spread out that data is. So our average data, 41 plus 16 plus 17, our average age is 24.6 repeating years, okay? And let's see how far spread out it is. So one measure of spread would be 41 is just the range, highest minus the lowest. 41 minus 16 is 25. Now let's say we converted this into inches. Okay, these are years, right? So let's say we convert it into months. So instead of this being our year, right? Let's convert it into months. Well, that should be fine. So instead of 41 months, there's 12 months in a year. So 41 times 12, oh my gosh, look how old I am. 492 months. 16 times 12, 192 months. If you're 17, you're 204 months. 492 plus 192 plus 204, divide by 3. So our average month is 296. Now, I could have done it a lot faster by just multiplying 24.6 repeating times 12. Yep, and I get exactly that answer. So we can convert just by multiplying. Did you notice how we did that? Now, let's see if the spread would change by multiplying, right? This is still 492 months because I'm 41 years old, and 16 years is still 192. So the range of our months would be 492 minus 192 is 300, and I bet 25 times 12 is 300. Yeah, so when we multiply, it totally changes the spread. Here's the problem though, it doesn't change when we add. So if I add an extra year onto everyone's life, let's say 2 years. Oh my gosh, it feels like this class is gonna add 2 years to everyone's life. So now we're 43, 18, and 19. Let's calculate our average age. I get 26.6 repeating. Oh wait, it just went up 2 years. That makes sense. So when I add something to the mean, if I add 2 to every number, it's going to add 2 to the mean, and it did. But let's see if it changes the spread. So I'm still 43 years old because I added 2, and the youngest person is 18. Uh-oh. So when I add 2 years to everyone's life, the spread didn't change. I still get 25. Oh, so that's number behavior. That's why the spread here shouldn't go up by 32. It should only go up by the multiplication factor. So spread only changes with multiply or division. It doesn't change by adding. Last but not least, the following histogram shows frequency for the stock exchange. The class contained the 80th percentile. So what you need to know is when is the 80th percentile, or the last 20%. So it's somewhere over here. So let's add these up. I get 13 plus 8 plus 15 plus 7 plus 2 plus 3 plus 1. 1 plus 1. And I get 50. So 50 is 100% of the data. So 50 times 80% of the data would be 40. So I'm looking for where is the number that's at the 40. So I could count 10 down from here or 40 up from there. So I'm going to count back 1, 1, 3. So that's 5, 6, 7, 8, 9, 10. So it falls somewhere in here. So right here is when you're at the 80th percentile point, and that's between 30 and 40. And so I'm going to circle that. So the upper 20% of people, or excuse me, the upper 20% of this particular price on the stock exchange fell right in this histogram. We could also add this up, and again, that would be the lower 40, and this is the top 10. And again, the reason why I'm getting 10 and not 80 is that if you only have 50 numbers, the top 10 numbers are in the upper 20%. And the upper 20% is another way to say the 80th percentile. Thanks for joining us.